Start, madam.
Okay. Good morning, everyone. You all are aware that this pandemic has disturbed our lives drastically. So to cope up with the education of our children, we have started second-year webinars long back in June 2020. Since then, we have been working hard to give our best to our students. Now, we are back to deliver our best. Our Mathematics 2A subject consists of a very interesting topic called partial fractions. So today, Mrs. E. PURNIMA, PGT TSMS Valigonda Yadadri district, will showcase her talent. She has an experience of 6 years before joining model schools in 2013. She is also a recipient of Best Teacher Award in St. George's Grammar School. Now, over to Purnima, madam.
Thank you, ma'am. Good morning, children. Welcome back to the webinar. I hope everyone is doing good. So today we are going to start our new chapter, partial fractions, which is very much useful to you in the integration chapter of 2B. So let us start our topic, children. So everyone be ready with your book and pen. So what is our chapter in 2A? It is the 7th chapter, which is called as a partial fractions. Is it clear, children? So here, what is a partial fraction? Yes. So before going to that, we need to have some overview of the partial fractions chapter. What we are going to see in the chapter. So here the partial fractions, in the partial fractions chapter, we have rational fractions. The first topic we are dealing is what? Rational fractions. And the next one is partial fractions with irreducible factors. Next one is partial fractions with non-repeated linear factors. Next one is partial fractions with repeated linear factors. Next one is partial fractions with non-repeated quadratic factors. And the next one is partial fractions with repeated quadratic factors. So these are all the topics which you are going to see in the partial fractions chapter and which we are going to use in our integration chapter also, which I told you already. Okay, so let us see the learning points of today's class. So what you are going to learn in today's class. First one is definition of a rational fraction. So what is a rational fraction? And the next one is proper and improper fractions. And third one is reducible polynomials. Next, irreducible polynomials. Next one is partial fractions of f of x by g of x, which is a fraction with non-repeated linear factors. So these are the things which you are going to learn. Clear, children? So now here, so first of all, let us see what is a rational fraction. So now here, what is a rational fraction? So before going to that, let me ask you one sum. It's a simple sum which you already learned in your lower classes, not the 9th and 10th, in 6th class. Yes. So let us see a fraction 1 by 6. How can I split 1 by 6? It can be written as 1 by 2 minus 1 by 3. Isn't it? Yes or not? So now here I can take another example here. Just I'm taking here 5 by 6. How can you write 5 by 6? It is written as 1 by 2 plus 1 by 3. So if you observe these two examples, these two fractions, here 1 by 6 is written as difference of two fractions. Here 5 by 6 is written as sum of two fractions. That means what? Any fraction can be divided into difference of two fractions or sum of two fractions. Not only two fractions, children, it can have many number of fractions also, more than two also. Yes or not? So in this example, we are here we are dividing it into difference of two fractions, and here it is sum of two fractions. So now here, so how it is connected to our partial fractions? Let us see. So let us see another example here. 2 by x plus 1 plus 3 by x plus 2 is equal to how much? So what is this here? Here we have a fraction. In the previous examples, we are seeing only the fractions with numeric values. Yes or not? But here we are having a fraction with, what is this? It's a polynomial. Yes or not? So 2 by algebraic expressions. So it is what? 2 by x plus 1 plus 3 by x plus 2. So then how to add this one? Yes, you are right. You have to take here LCM. Yes or not? So let us see. So what is the solution of this sum? 2 by x plus 1 plus 3 by x plus 2 is equal to. So what we do here? We take the LCM. So that is 2 into x plus 2 plus 3 into x plus 1 by x plus 1 into x plus 2. We have taken the LCM as x plus 1 into x plus 2. So which will be 2 into x plus 2 plus this 3 into this factor which is x plus 1. So now what is the next step here? Expanding the brackets. That is 2x plus 4, 2 2s are 4 plus 3x plus 3 1s are 3 by x plus x into x is x square plus 2 into x is 2x, 1 into x is x, 1 into 2 is 2. Here it is 2x plus 3x is 5x, 4 plus 3 is 7, x square plus 2x plus 3x is how much? 3x plus 2. Okay. Now here, so this is the sum what we have got. Now here, so by seeing that example, you may get a doubt. Let us see here. How can you split 5x plus 1 by x plus 2 into x minus 1 into sum of two fractions? And similarly, how can you split 2x plus 3 by x plus 1 into x minus 3 into difference of two fractions? So as you have seen two fractions in the earlier examples, as you have seen, a fraction is split into difference of two fractions and as well as sum of two fractions. Yes or not? So similarly, here instead of taking a fraction with only numerical values, here I am taking a value, I am taking a fraction with algebraic expressions. Yes or not? So what is here? What is the first one? 5x plus 1 by x plus 2 into x minus 1. Similarly, 2x plus 3 by x plus 1 into x minus 3. So how can you split them into sum of two fractions and difference of two fractions? So let us see how we are going to do that. So now here, so that before going to see that, to know that how to do, we need to have a concept of rational fraction. So what is a rational fraction, children? So here it is. If f of x and g of x are two polynomials and g of x is a non-zero polynomial, then f of x by g of x is called a rational fraction. So what is a rational fraction, children? If f of x and g of x are any two polynomials and g of x is a non-zero polynomial, then f of x is by g of x is called a rational fraction. Here I am saying that first thing is f of x and g of x are two polynomials. Yes. So in this fraction f of x by g of x, the numerator f of x and the g of x denominator g of x both must be polynomials. So what do you mean by a polynomial? You learned it in the lower classes. Yes or not? Yes. So now let us recollect the concept of polynomial once. So what is a polynomial? A polynomial is an algebraic expression which should have non-negative integral powers. The variable should have non-negative integral powers. So in the numerator here we have f of x. So it should have a non-negative integral powers. And here also in the g of x also the variable x should have non-negative integral powers. So now here if you see them together, that is as f of x by g of x, both must be polynomials. And similarly g of x is a non-zero polynomial. That means where is the g of x here? Yes, you are right. G of x is in the denominator. So the denominator should be a non-zero polynomial. Why I am saying here non-zero? Because if it is a zero polynomial, then what happens? F of x by 0 is what? F of x by 0 is what? It is 0. Sorry, f of x by 0 is what? It is an undefined expression. It becomes undefined expression. So whenever you are doing this, you should not get any undefined expression. So here it must be what? It must be what? A non-zero polynomial. So then it is called as a rational fraction. So now here let us see an example for rational fraction. So it is what I am giving here, 2x plus 7 by x square plus x minus 2. So if you observe this expression, this fraction, the numerator is a polynomial and the denominator is also a polynomial. What kind of polynomials they are? The numerator is a linear polynomial and the denominator is a quadratic polynomial. Do you remember, children, in 10th class you have learnt it? Yes. What is a linear polynomial? The polynomial whose degree is 1. So here, if you observe the numerator, the degree of x is what? The degree of the polynomial in the numerator is 1. So it is a linear polynomial. And here the highest power is how much here for x? It is 2. So it is the degree is considered as 2 and it is a quadratic polynomial. So the numerator and denominator, together if you write, it is a f of x by g of x considered as a rational fraction. Yes. Let us see another example. X cube plus 2x plus 5 by x square minus 2. So what is this? In the numerator we have cubic polynomial because the degree is here 3 and the denominator again degree is 2. So it is a quadratic polynomial. So these two are the examples given for rational fraction. I hope you are following, children. Yes. So next one is, so now when you are saying the rational fraction is of two types. So what are the two types, children? Rational fraction is divided into two types. What is that? The first one is a proper fraction and second one is improper fraction. So what is the first one? It's a proper fraction and second one is improper fraction. So these two are called as rational fractions only, but specifically by the terms in f of x and g of x, we specify them as proper fraction or improper fraction. So let us see one by one what is a proper fraction. So what is a proper fraction? Let us see here. A rational fraction f of x by g of x is said to be a proper fraction or is called a proper fraction if the degree of f of x is less than the degree of g of x. So what is a proper fraction, children? Rational fraction f of x by g of x is called a proper fraction if the degree of f of x is less than the degree of g of x. So f of x by g of x is a rational fraction, is or not? So in this, numerator is f of x and denominator is g of x. So the degree of the numerator should be less than degree of denominator. Then it is said to be what? Proper fraction. So let us see with an example. So what is the example here? 2x plus 7 by x square plus x minus 2. So what is this here? In the numerator we have a linear polynomial, yes or not? In the denominator we have a quadratic polynomial. So what is the degree here in the numerator? Degree is 1. And what is the degree of the denominator? Degree of denominator is 2. So it means what? If you observe here, the degree of the numerator is less than degree of denominator or not? Here the degree is 1 and here the degree is 2. So obviously the numerator's degree is less than denominator's degree. So this fraction is called as here a proper fraction. So let us see another one. So next one is here the improper fraction. The second kind of rational fraction is what? Improper fraction. So what is an improper fraction? So a rational fraction f of x by g of x is called an improper fraction if the degree of f of x is greater than the degree of g of x. So it is reverse to that one, yes or not? So there what we have learned, the degree of f of x should be less than degree of g of x. Here what we are seeing here, the degree of f of x is greater than the degree of g of x. Yes. So let us see with an example here. What is the example here? 3x square plus 2x plus 1 by 4x plus 3. So if you observe here, the numerator is having degree 2 and the denominator is having degree 1. So from here what can you say? The degree of the numerator is more than degree of denominator. So can you say here it is an improper fraction? Yes. So it is an improper fraction because degree of numerator is greater than degree of denominator. So it is an improper fraction. I hope children you are following. What is a proper fraction? The degree of f of x should be less than degree of g of x. Then it is a proper fraction. And what is an improper fraction? If degree of f of x is greater than the degree of g of x, then it is called as an improper fraction. So let us see here. Here, let us see with an example. X cube minus 2x. X cube minus 2x square plus 6 by 3x plus 5. So here what is here? Numerator's degree is 3 and the denominator's degree is 1. So this is the second example, children. So here it is again the degree of numerator is more than degree of denominator. So it is also an example of an improper fraction. Is it clear, children? So now here let us see the new topic here. Reducible polynomial. So what is the meaning of reducible polynomial? So till now we have seen the types of fractions. So not a rational fraction. It is divided into two fractions, that is proper fraction and improper fraction. Now what is here? A reducible polynomial. So when you are saying here reducible, what is the meaning of reducing? So what is the meaning of reducing, children? Yes, it is nothing but it is the degree should be reduced, because when you are talking about a polynomial, what can be reduced here? The polynomial can be a polynomial cannot be reduced. What can be reduced in a polynomial? The degree of the polynomial is reduced. That means it is split into some other polynomials which has lesser degree than the original one. So let us see what is the definition of a reducible polynomial. If a polynomial f of x is expressed as the product of the polynomials g of x and h of x, such that the degree of each polynomial is less than the degree of f of x. So then f of x is called or is said to be a irreducible polynomial. So what is it? A polynomial f of x is expressed as the product of the polynomials. So whenever a polynomial f of x is given to us, so what we should do? It should be expressed as, it should be reduced as g of x and h of x, product of g of x and h of x. These two are also polynomials. G of x is a polynomial and h of x is also a polynomial. So if you are able to do that, and how can you reduce that? What is the condition? Already I told you. Yes, a polynomial, how a polynomial should be reduced? Such that the degree of g of x and degree of h of x should be less than the degree of f of x. Okay, so then we say that f of x is said to be a reducible polynomial. So if it is possible, if this condition is possible, if you are able to express them as product of g of x and h of x, then only we say that it is a reducible polynomial. So let us see how it can be done. So here, let us see an example here. F of x is equal to x square minus 4. So as you see here, x square minus 4 means what? 4 can be written as, how can you write 4? X square minus 4 is equal to x square minus 2 square. Yes or not? 4 is nothing but 2 square. So it is in which form? A square minus b square. Do you remember the formula? Yes. So what is here? It is in the form of a square minus b square, which is nothing but a plus b into a minus b. So it is written as x square minus 4 is equal to x plus 2 into x minus 2. So that means what? Here the given polynomial is x square minus 4, whose degree is 2. And it is written as product of two factors. This is the first factor and this is the second factor. So what is the degree here? Degree of the first factor is 1 and degree of the second factor is 1. And what is the degree of the given polynomial? 2. That means that these are the reduced polynomials whose degree is less than f of x or not. So let us see here. X square minus 4 is nothing but f of x. And what you are considering? The first factor x plus 2 I am considering as g of x. And the second factor x minus 2, it is considered as h of x. That means what? The polynomial, the given polynomial f of x is reduced or is written as the product of two other polynomials. What are they? One is g of x and other one is h of x, whose degree is lesser than, yes or not, lesser than the given one. So let us check it once. Degree of f of x is equal to how much? It is 2. And what is the degree of g of x? This is the g of x term what we are considering. It is 1. And what is the degree of h of x? It is our h of x. Yes. So what is the degree of this? It is also equal to 1. So from these three, what can you observe? Degree of g of x is less than f of x. Degree of h of x is also less than f of x. Yes or not? So what you are understanding here? Degree of g of x is less than degree of f of x. Next one is degree of h of x is less than degree of f of x. Okay. So now here it is nothing but here in this case, what can you say here? The given polynomial x square minus 4 is what? It is a reducible polynomial, because here you are able to reduce. Here you are able to reduce it into product of two factors whose degree is less than the degree of f of x. So it is called as a reducible polynomial. Is it clear, children? So now here let us see with an example here. Another example, f of x is equal to x square plus 5x plus 6. So now here, what is this here? It is nothing but a quadratic polynomial with 3 terms are there. In the previous example, there were only 2 terms. So there it was easy to split it in the form of a square minus b square. Yes or not? But here it is not possible in such a way. Then how can you write this? So it is a quadratic polynomial. You learnt in 10th class. Yes or not, children? Which method? How can you split it into factors? Yes, you can do it with the factorization method. So let us see here. So f of x is nothing but x square plus 5x plus 6 is equal to. So how can I write this? X plus 2 into x plus 3. How did I get it? How did I get it as x plus 2 into x plus 3? So let us see it. So now here, what is the polynomial? X square plus 5x plus 6, which is written as x square plus 5x can be written as 2x plus 3x plus 6. So in these two we can take x common, that is x plus 2, plus in these two we can take 3 common, which is x plus 2. So here it again x plus 2 is taken common, which is x plus 3. So that means what? It is a factorization method. Yes, in 10th class we learnt it. Yes. So x square plus 5x plus 6 is written as x plus 2 into x plus 3. Again here this is our f of x. It is written as product of two factors. One factor is taken as g of x and other factor is considered as h of x. So now let us check the degrees of them. Okay. So what is the degree of f of x? The given polynomial degree of f of x is 2. And what is the degree of g of x? The first one, which is x plus 2. So what is the degree here? It is 1. And what is the degree of h of x? The second factor, which is whose degree is equal to 1. So from the three statements, what can you understand? Degree of g of x is less than degree of f of x. Again, degree of h of x is less than degree of f of x. So from here, what can you say? Again, the given polynomial f of x, here also it is also called as a reducible polynomial. Why it is reducible? Because here you are able to write this as a product of two linear factors. So product of two linear factors. So linear is nothing but obviously the degree of a linear polynomial is less than degree of a quadratic polynomial. Yes or not? So it is called as a reducible polynomial. So now here children, let us see what is an irreducible polynomial. Till now we are talking about reducible polynomial. What is irreducible polynomial then? Yes, you are right. It is opposite to reducible polynomial. Means what? A polynomial f of x is said to be irreducible if it cannot be expressed as a product of the polynomials of g of x and h of x, such that the degree of each polynomial is less than the degree of f of x. So what is the definition of irreducible polynomial? A polynomial f of x is said to be irreducible if it cannot be expressed as a product of the polynomials of g of x and h of x. So in the previous definition, reducible, what have we learned? It should be expressed as a product, yes or not? But what is irreducible if it cannot be expressed? So it is a opposite one or not? So f of x, if you cannot express f of x as a product of the polynomials g of x and h of x, then such that the degree of each polynomial is less than degree of f of x. So if you are unable to do such thing, then it is called as an irreducible polynomial. So let us see here an example. 5x plus 3. So what is this here? It is a linear polynomial, yes or not? Because here the degree is 1. Yes. So here the degree is 1. Now it is an it is a linear polynomial. So can you still further reduce this, or can you split it into product of any other two factors? Because it itself is the lowest degree, yes or not? So what is the, because here the degree is 1, what is the lesser degree? Less than 1 is what? 0, because we cannot take the negative powers, yes or not? Because if you take the negative powers, then that is not at all a polynomial, because a polynomial itself should have a non-negative integral powers. So we can have only non-negative integral powers. So here if you see, the x has only power as 1, that is degree as 1. So what is the lesser degree? It should be 0. Other than 0, there is no other possibility. But the degree 0 is what? For which polynomial we have a degree 0? It is a 0 polynomial, yes or not? So only a 0 polynomial has degree 0. That means what? But a 0 polynomial, does it make any sense taking a 0 polynomial? So no, yes or not? So it doesn't make any sense. So that means what? Here there is no scope of reducing this linear polynomial further, yes or not? So that's why it is called as what? An irreducible polynomial. And the next example is, example number 2 is x square plus 2. So here what is this? It is a quadratic polynomial. What I am taking here? I am taking here a quadratic polynomial. What is a quadratic polynomial? It is the polynomial which has degree 2. So now here it is a degree 2 is there here. So we can, in the previous example we have seen a quadratic polynomial is split into product of two factors. But why I am saying here it is an irreducible polynomial? Why I am saying here? Because here you are unable to split into product of two linear factors. Why it is so? Let us see. Okay. So here I am saying it as an irreducible polynomial. Means all quadratic polynomials are not irreducible, children. Some are reducible and some are irreducible. So here you may get a doubt. How can we identify? Yes or not? So what is another example? X square plus x plus 1. Here also I am taking a quadratic polynomial. So in these two cases, these two are quadratic polynomials, but still I am saying them as irreducible polynomials. Whereas in the previous example, we have seen a quadratic polynomial is a reducible polynomial. So here, yes sir, is it giving you a doubt? So what is the doubt you are expressing? How can we identify an irreducible polynomial? Is it doubt came to your mind? Very good, children. So it is a very good doubt, valid doubt. So how can we identify an irreducible polynomial? So let us see. So let us see it by points. First one, every linear polynomial is irreducible. So what is the thing here you have to remember? Every linear polynomial is always irreducible. Means we cannot further reduce a linear polynomial. Whatever is a linear polynomial, it is always irreducible. Yes. So example, 5x plus 3. Okay. And second one is a quadratic polynomial. Ax square plus bx plus c is irreducible if and only if b square minus 4ac is less than 0. Yes, do you remember this expression, children? Ax square plus bx plus c. It is general form of a quadratic polynomial. So this quadratic polynomial is irreducible if and only if b square minus 4ac is less than 0. Do you remember this formula? Is it familiar to you? Yes. So what is this? It is a discriminant formula. While finding the nature of the roots, we used this formula. Yes or not? So b square minus 4ac, if it is less than 0, that means if discriminant value is less than 0 for the given quadratic polynomial, then we say that the quadratic polynomial is irreducible. So whenever a quadratic polynomial is given to you, we can verify. We can verify whether b square minus 4ac is less than 0 or not. If it is so, then it is irreducible. Otherwise, it can be reduced. Reduce it to what? Reduce it to product of linear factors. Product of two linear factors, as you have seen in the previous example. Is it clear, children? So let us see an example here. So here I am giving you an example. F of x is equal to 3x square plus 2x plus 1. So what are the, if you compare this expression with the general expression, that is ax square plus bx plus c, what are the values of a, b, c? Let us write them first. A is equals to 3, b is equal to 2, c is equal to 1. Now here b square minus 4ac is equal to 2 square minus 4 into 3 into 1, which is nothing but 4 minus 12, which is minus 8, which is less than 0. So what is the b square minus 4ac value I got? I got it as a negative value, which is less than 0. So here, what is our condition? If this is b square minus 4ac is less than 0, then what is the polynomial? It is irreducible. So then what is our polynomial in this case? It is 3x square plus 2x plus 1. Now it is called as what? It is an irreducible polynomial, isn't it? Because the b square, the discriminant value b square minus 4ac is less than 0 here. So that's why it is called as an irreducible polynomial. Is it clear, children, how to identify them? First thing is, every linear polynomial is irreducible. Here no need of any checking. If you see the degree as 1, then directly we can say that it is a irreducible polynomial. And what is the second one? If it is a quadratic polynomial, then we have to check, we have to verify whether discriminant is less than 0 or not. So then if it is so, then it is irreducible. Otherwise it is reducible. Clear? So now next one is, let us come to our topic, partial fraction. So now here till now we have gone through the rational fraction, proper fraction, improper fraction, and what is the next thing? Reducible polynomials and irreducible polynomials. So what is then what is our main topic is what? Partial fraction. So what is a partial fraction? So let us see the definition first, then I'll explain. If a proper fraction is expressed as the sum of two or more proper fractions wherein the denominators are powers of irreducible polynomials, then each proper fraction in the sum is called a partial fraction of the given fraction. So what is this, children? If a proper fraction is expressed as the sum of two or more proper fractions. So already we have seen with the examples, no, children? So whenever a proper fraction is expressed as sum of two or more number of proper fraction, means a fraction can be written as sum of the fractions or not. Yes. So if you are able to write, if a proper fraction is written as sum of two or more number of proper fractions, wherein the denominators are, so wherein the denominators, whenever you are saying a fraction, it has a denominator, so not. So wherein the denominators are powers of irreducible polynomials. So the denominators are the powers of irreducible polynomials. Then each proper fraction in the sum is called a partial fraction. Means what? When you are writing a proper fraction as sum of some two or more fractions, then each fraction is said to be a proper fraction. So what is it? Let us see here. F of x by g of x is our proper fraction. Okay. So I'm splitting it into f of x1 by g of x1, which is the first proper fraction, plus f of x2 by g of x2, which is the second proper fraction, plus f of x3 by g of x3, plus so on. So it means what? Here f of x by g of x is a proper fraction if it is split into f of x1 by g of x1 plus f of x2 by g of x2 plus f of x3 by g of x3 plus so on. So you can write it into any number of sum of the fractions. Yes. So that means what here? Each term in this sum, each fraction is said to be a partial fraction. When it is said to be a partial fraction, if the denominators, what are the denominators? Here g of x1, g of x2, g of x3 and so on. So if the denominators are irreducible polynomials, so there should be a irreducible polynomial. Here g of x1 should be an irreducible polynomial, G of x2 should be an irreducible polynomial, so on. Okay, so like this, if it is so, then we say that each term or each proper fraction here in the sum is called as what? Partial fraction. So let us see what is it here. So where g of x1, comma g of x2, comma g of x3 and so on. They are what? They are the irreducible polynomials. Here it is the condition. It should be the condition. Then only we say that f of x1 by g of x1 and this third one and so on. How many terms are there in this sum? In all the terms, each fraction is called as a partial fraction. Is it clear, children? So now here, then what happens here? F of x1 by g of x1, f of x2 by g of x2, f of x3 by g of x3, so on are called as what? Partial fractions of what? Of the given fraction f of x by g of x. Here the condition is what? The g of x1, the denominators should be irreducible polynomials. Is it clear, children? So let us here move on to the next thing, example here, which is 2x by x square minus 4 is written as 1 by x plus 2 plus 1 by x minus 2. So here, what is the expression I have given here? What is the equation I have given here? 2x by x square minus 4 is equal to, is split into sum of two fractions. So it is our f of x by g of x. I am writing it into sum of two fractions. What is the first fraction? 1 by x plus 2 plus what is the second fraction? 1 by x minus 2. Okay, so now here let us see, is it true or not? See, I'm giving you here, so we should verify whether it is true or not. How to verify? Let us start from the RHS and come to the LHS. So verification part, let us see. So what is RHS here? 1 by x plus 2 plus 1 by x minus 2 is equal to. So what to do here, children? Here what we do? X plus 2 into x minus 2 is LCM. 1 into x minus 2 is x minus 2 plus 1 into x plus 2 is x plus 2. So now here what happens? Here if you see, this plus 2 and minus 2 are cancelled. If these 2 are cancelled, what we get? X plus x is 2x by x plus 2 into x minus 2. So which is 2x by, it is in the form of a plus b into a minus b, which is nothing but a square minus b square, that is x square minus 2 square is 4. So which is equal to our given sum, that is LHS. Yes or not? So is it verified, children? 2x by x square minus 4 is equal to 1 by x plus 2 plus 1 by x minus 2. Yes, is it verified or not? Yes. But here, by seeing this sum, see, here I have given you the fractions. Means what? I have split into this into two fractions. So here, then how can we split? You may get a doubt. Yes or not? So how to divide a proper fraction into partial fraction? Here again you may get a doubt. Yes. So let us see how to divide a proper fraction into partial fractions. So let us see it one by one. So here, to see that, we are going to see the rule 1 of this. So what does the rule 1 tells us? Partial fractions of f of x by g of x, when g of x contains non-repeated linear factors. So when you are dividing a partial fraction, when you are dividing a given proper fraction into partial fractions, so what is the rule 1 here we are seeing? The rule 1 tells us partial fractions of f of x by g of x. It is our proper fraction. Okay, when g of x contains non-repeated linear factors. So what is the g of x? G of x is a polynomial in our denominator. Yes, so it should contain non-repeated linear factors. If g of x has non-repeated linear factors, then how to divide the fraction into partial fractions? Let us see. So let f of x by g of x be a proper fraction. To each non-repeated factor ax plus b of g of x, there will be a partial fraction of the form a by ax plus b, where a is a non-zero real number, which is to be determined. So what is here? What does rule 1 tells us? let f of x by g of x be a proper fraction to each non-repeated factor, because here the condition is what, here what you are saying, g of x should contain non-repeated linear factors, yes or not? So to each non-repeated factor ax plus b of g of x, means in the g of x, for every how many non-repeated factors are there, that may for each such factor we have a partial fraction of the form a by ax plus b, where this a is the constant which is to be determined. It is a constant. Which type of constant it is? It is a non-zero real number. We are saying non-zero means it should not be zero. Other than zero, it can be anything. Because why you are saying it as non-zero? Because if it is zero, then what happens? Zero by something is always zero, yes or not? So there is no partial fraction at all. If the whole term becomes zero, then there is no partial fraction at all, yes or not? So that's why here we are saying it should be the constant a should be a non-zero real number. It can have negative value, it can have positive value also. Okay, so let us see here with an example. What is the example? First example, resolve 5x plus 1 by x plus 2 into x plus 2 into x minus 1 into partial fractions. So what is our fraction given to us? 5x plus 1 by x plus 2 into x minus 1. So this is our proper fraction given to us into partial fractions. Why I am saying it as a proper fraction, children? Because the numerator is having degree 1, because it is a linear polynomial, yes or not? Its degree is 1. Whereas in the denominator, it is a product of two factors. When you multiply them, what happens? X into x becomes x square, yes or not? That means the degree is how much here? 2. So the numerator's degree is less than denominator's degree. So it is called as a proper fraction. Yes. So what you are doing here? What is our question? Resolve 5x plus 1 by x plus 2 into x minus 1 into partial fractions. So let us see how to do this. So first of all, according to the definition, for each non-repeated linear factors, we have a partial fraction. So what is the first factor here? It is x plus 2. So for this because it is a linear polynomial, it cannot be reduced further, yes or not? So for the first linear factor, one partial fraction, and for the second linear factor, for the second non-repeated linear factor, second partial fraction. So why I am saying it as non-repeated? Because the x plus 2 is only once, x minus 1 is also there only once. So it is a non-repeated terms. So for the first x plus 2, I have written the first partial fraction as a by x plus 2 plus for the second term, for the second linear factor, non-repeated linear factor, I have written as second partial fraction as b by x minus 1. See, you have to take here. The first one is for the first partial fraction, constant is a. In the second partial fraction, we cannot take the same a, yes or not? So for that, it's taking another constant as b. Clear? Otherwise, we can take a1, a2, so on. Like that also we can take a, b, c, d also we can take. It is up to you. Okay. So next one here, what is the next step? Here, these two should be taken LCM. For these two fractions, we have to take LCM. So what is here? A and b are the non-zero real numbers which are to be determined. Now here 5x plus 1 by x plus 2 into x minus 1, which is our LHS, is equal to, what is LCM? X plus 2 into x minus 1 is the LCM. A into x minus 1 plus b into x plus 2. Yes, this is a step after taking LCM. So now here, what is our step? Again, I am writing here, children. This is the step what we got. 5x plus 1 by x plus 2 into x minus 1 is equal to a into x minus 1 plus b into x plus 2 by x plus 2 into x minus 1. So if you observe the two fractions on either side, here the denominators x plus 2 into x plus 1, x plus 2 into x plus 1. Here also on the LHS also we have x plus 2 into x minus 1. Yes or not? So these two denominators can be cancelled. X plus 2 into, here also we have x plus 2, x minus 1, and here also we have x minus 1. Both can be cancelled. So what is left after cancelling the denominators? What is left? 5x plus 1 is equal to a into x minus 1 plus b into x plus 2. So let us take this as equation number 1. So now here these are the two values what you are going to find out now. A and b. So first thing is how to find out this A and B. So now if you observe here children, the what is the product here? What is the product means what is the term here? We have x minus 1. Suppose here if I take this x is equals to 1. Suppose here if I substitute x is equals to 1, then what happens? 1 minus 1, this term becomes 0 or not? So here then what happens here? If I substitute 1, what happens? 1 plus 2 becomes 3. So this term is totally getting eliminated. So that means what? From here we can directly get the value of b. So here in such cases what we should do? First we have to check for the linear polynomials whatever are there. For that linear polynomials, by giving which value one term is eliminated. Like that we have to check. So let us see here, putting x is equal to 1 in equation number 1. So what we get? 5 into 1 plus 1. On both the sides we have to substitute wherever x is there. 5 into 1 plus 1 is equal to a into 1 minus 1 plus b into 1 plus 2. So now here 5 into 1 is 5. 5 plus 1 is equal to, this term is 0, plus 1 plus 2 is 3. 3 into b. 5 plus 1 is 6. Yes, is equal to 3b. So 3 into b is 3b is equal to 6. This term has got eliminated. Okay. Now what is b here? 6 by 3 is nothing but this 3 goes here. Yes or not? As a denominator. 6 by 3 is equal to how much now? 2. So what we got here by substituting x is equals to 1. How did I get x is equal to 1 here? Because here I have the linear factor. So based on the linear factor, what we have here, we have to see by giving which value for x here. This term will get eliminated. This term eliminated means what? This term should become 0. This if this term becomes 0, then this whole term will get eliminated. Yes or not? So like that you have to see according to the linear factor. Then what is our second linear factor? X plus 2. Yes. So then what should be the x value here, children? By giving how much here, this term becomes 0. Because here we need to get the value of a, no? Yes. So by giving how much value here, we should get, we'll get it as 0. Here already plus 2 is there. So how much you should have here? Yes, you are right. It should be minus 2. So let us do that. Okay. So 5x plus 1 is equal to a into x minus 1 plus b into x plus 2. This is the equation what we have. Here we are going to write putting x is equals to minus 2 in equation number 1. So 5 into minus 2 plus 1 is equal to a into minus 2 minus 1 plus b into minus 2 plus 2. So here what is 5 into minus 2? It is minus 10 plus 1 is equal to a into minus 3. That is minus 3 into a plus b into 0. So what is here? B into 0 is nothing but 0. So this term has got eliminated. So what is left here? Minus 10 plus 1 is nothing but minus 9 is equal to minus 3a. So minus 3 I am writing here, children. So here it is nothing but on both the sides. On both sides what happens? Minus sign and minus sign gets cancelled. So 3 goes other side, becomes 9 by 3, which is 3. Okay. So a is equal to how much, children, here? 3. Now what are the values of a and b we got? A is equal to 3 and b is equal to 2. So let us replace them in the first equation. So what is that? A is equals to 3, b is equals to 2, and what we have? We are divided into partial fractions, no? So in the first step that we are going to see now. 5x plus 1 by x plus 2 into x minus 1, which is our given fraction. A by x plus 2 plus b by x minus 1. So these are the partial fractions which you have split into. Yes or not? Now here in place of a and b, let us replace these values. So then what happens? 5x plus 1 by x plus 2 into x minus 1 is equal to how much? In place of a, how much you should take? 3. 3 by x plus 2 plus 2 by x minus 1. So like this we have to split the given fraction, given proper fraction into sum of the partial fraction. Is it clear, children? So whatever are the terms here in the denominator, they should be non-repeated linear factors. For each non-repeated linear factor, we get one proper fraction. So like this, how many terms are there in your given fraction? So that many partial fractions we get. Here I have 2. 2 factors are there. So I got 2 fractions. Suppose if I have here 3, one more factor, then I'll get one more proper fraction here. Is it clear, children? So let us see another example here. So what is the next question? Resolve 3x plus 7 by 3x plus 7 by x square minus 3x plus 2 into partial fractions. Okay. Now what is the sum here? 3x plus 7 by x square minus 3x plus 2 into partial fractions. So let us see how to do this. So now here the denominator, what is given? 3x plus 7 by x square minus 3x plus 2 is there. X square minus 3x plus 2 is what? It is a quadratic polynomial. So let us see, can you split into partial, what is that, linear factors or not? Product of linear factors. So we can write it as x square minus 2x minus x minus 3x can be written as minus 2x minus x plus 2. So now here, what is the next step? Taking x common, x minus 2, minus 1 is taken common, x minus 2. So again, x minus 2 is taken common, x minus 2 into x minus 1. So that means what? The given quadratic polynomial is split into product of two linear factors. Then what is it called? Already we have discussed. It is a reducible polynomial, yes or not? Yes. So it is reduced into product of two linear factors. So let us write our sum again. What is our question here? Let 3x plus 7 by x square minus 3x plus 2, which is nothing but 3x plus 7 by, in place of this quadratic polynomial, I am writing these two factors, x minus 2 into x minus 1. So if you observe here, it is now similar to the previous example or not? Here we have two non-repeated linear factors. So for the first factor, I got a first partial fraction, that is a by x minus 2, plus for the second term, second non-repeated linear factor, I got second partial fraction, which is b by x minus 1, where a and b are the constants which are to be determined, which is non-zero real numbers which are to be determined. Yes. So let us see how to find it. Similar to the previous example only, children. So these are the partial fractions what you have done. Let us see here. First thing is what you have to do here. Let us take the LCM. 3x plus 7 by x minus 2 into x minus 1 is equal to. So what is LCM here, children? A into x minus 1 plus b into x minus 2 by x minus 2 into x minus 1. So this is the LCM what we got. Okay. So after taking LCM, these are the terms in the numerator we got. Clear? So if you observe the two terms on both the sides, again here the two denominators are same. So not. So we can cancel them as we did in the previous sum. Okay. X minus 2 is cancelled. Here also x minus 2. Here x minus 1. Here also x minus 1 are cancelled. So what is left then after cancellation? 3x plus 7 is equal to a into x minus 1 plus b into x minus 2. So it is again we have come to the same statement, which is our equation number 1. Now here we have to eliminate any one of the constant term. So which term we can, anything, it is up to us. Okay. So if you eliminate b, then we'll first get value of a. If you eliminate a first, then we get value of b first. Okay. So it is like that. So now here for the first term, to eliminate this first term, what you should do? I have to substitute x is equals to 1. 1 minus 1 becomes 0. To eliminate this term, in place of x, what I should put? I should put 2. So if I put 2 here, 2 minus 2 becomes 0. Yes or not? So let us see how to do it. So by putting x is equal to, one in equation number 1, what I get? 3 into 1 plus 7 is equal to a into 1 minus 1 plus b into 1 minus 2. So 3, nothing but 3 into 1 is how much? 3. 3 plus 7 is equal to a into 0 plus the 1 minus 1 is 0 now. So that's why here a into 0 plus minus 1 into b. Now 3 plus 7 is 10. 10 is equal to minus b. That is minus b is equal to 10. Or b is equal to how much? B is equals to minus goes other side becomes minus 10. So this is the value of b. Now similarly we will find out the value of a. So let us see here. So this is our equation. So by substituting, how much this term will get eliminated? This term will get eliminated. Yes, you are right. It should be 2 here. So by putting x is equals to 2 in equation number 1, what we get? 3 into 2 plus 7 is equal to A into 2 minus 1 plus B into 2 minus 2. So 3 2s are how much? 6 plus 7 is equal to A into 2 minus 1 is 1 plus B into 0. So this term is now 0. A into 1 is A and 6 plus 7 is 13. So what is the value of A now? A is equals to 13. So what we got? A is equals to 13 and B is equals to minus 10. So let us substitute here. A is equals to 13, B is equals to minus 10. And what is our equation of partial fractions? This is the equation of partial fractions where we are going to substitute the values of A and B. So 3x plus 7 by x square minus 3x plus 2 is equal to 13 by x minus 2 plus minus 10 by x minus 1. So here what is the final statement here? 3x plus 7 by x square minus 3x plus 2 is equal to 13 by x minus 2 plus into minus is minus 10 by x minus 1. So in this sum we got the proper fraction is divided into difference of two partial fractions. In the previous example, in the previous sum what we got it as sum of two partial fractions. Here we got difference of two partial fractions. And here one more point I want to tell you children. Here this is also a correct step. Okay, if you leave the sum here also, then also it is correct. But if you multiply this plus into minus and put minus sign here, it is also right. Okay, in both the cases it is right. Clear? So nothing to don't get confused here. If you leave here also it is right, here also it is right. If you write here, it is showing the sum of two fractions where b is a negative value. If you are showing here, it is the difference of two partial fractions. Okay, now here let us see next sum. Resolve x plus 4 by x square minus 4 into x plus 1 into partial fractions. So here what is this here? The denominator is having x square minus 4 into x plus 1. That means if you multiply this, what happens? X square into x is a x cube, which is a cubic polynomial. So that means what? A quadratic polynomial is split into two linear factors. A cubic polynomial should be split into three linear factors. Yes or not? So, but if you observe the sum, already we have one linear factor, which is x plus 1. So, only one quadratic factor is there, that is x square minus 4, which should be split into two linear factors. So, let us see how to do it. X square minus 4. Already in this example we have done children. X square minus 4 is written as what? 4 can be written as 2 square. So, it is a square minus b square formula. That is a plus b into a minus b, which is x plus 2 into x minus 2, and the given factor is x plus 1. So these are the product of three linear factors of our g of x. Okay, so now let us see here how to write the partial fractions of our given fraction. X plus 4 by x square minus 4 into x plus 1 is equal to x plus 4 by x plus 2 into x minus 2 into x plus 1, means I am replacing this x square minus 4 by the product of these two factors. Clear? Now this is a term what we have, this is a fraction what we have. So here if you observe, there are three linear factors, there are three non-repeated linear factors. So for each non-repeated linear factor we get a partial fraction. So here how many are there? So three terms are there, three factors are there. So we get three partial fractions. The first one is a by x plus 2 plus second one is b by x minus 2 plus third one is c by x plus 1. So like this, how many terms are there? That many partial fractions we get. So let us see here. So these are the terms what we have, where a, b, c are the non-zero real numbers which are to be determined. Okay. So let us see here. Let us take the LCM in the RHS. X plus 4 by x plus 2 into x minus 2 into x plus 1 is equal to what is here children? X plus 2 into x minus 2 into x plus 1, which is our LCM. Here a by x plus 2 is there. So I am multiplying with a into x plus 1 into x minus 2 plus b by x minus 2 is there. So that b should be multiplied with what? x plus the other two factors, that is x plus 2 into x plus 1 plus c into, here what we have, denominator we have x plus 1. So the c should be multiplied with the other two factors, x plus 2 into x minus 2. Okay. So again in the previous, like in the previous example, the three terms in the denominators, x plus 2 and here also x plus 2, x minus 2 and here also x minus 2, x plus 1 and here also x plus 1 are cancelled. Okay. Now what is left? X plus 4 is equal to a into x plus 1 into x minus 2 plus b into x plus 2 into x plus 1 plus c into x plus 2 into x minus 2, which is our equation number 1. Okay, this is our equation number 1. Now here, similar to the previous sum, here also we have to do the same thing. But here we have, instead of two constants, here we have three constants. Okay, only that difference is there. Rest of all, it is same. Now here, the first term, what are the values here? To eliminate this factor, what you should substitute for x? X should be replaced with minus 1. Yes or not? Minus 1 plus 1 becomes 0. And here, minus 2 means what? X should be substituted with 2. 2 minus 2 becomes 0. And what is the other term we have? X plus 2 is there. X plus 2 means what? Here x will be replaced with minus 2. Yes or not? So by doing such things, we will try to find out the values of A, B and C. So let us see here, children. Putting x is equals to minus 2 in equation number 1. So in the first equation, I am trying to put x is equals to minus 2. So by putting x is equals to minus 2, which terms I am going to eliminate? Wherever x plus 2 term is there, that becomes 0. So which terms are getting eliminated? Here we have x plus 2 and here also we have x plus 2. Yes or not? So these two terms are getting eliminated. Let us see now how it is. Minus 2 plus 4 is equal to a into minus 2 plus 1 into minus 2 minus 2 plus b into minus 2 plus 2 into minus 2 plus 1 plus c into minus 2 plus 2 into minus 2 minus 2. Okay. So what is it? 4 minus 2 is how much, children? Here it is 2. 2 is equal to a into minus 2 plus 1 is minus 1. Minus 2 minus 2 is minus 4 plus b into 0, because this term is 0. 0 into something is always 0 plus c into 0. So then it is now 2 is equal to minus into minus is plus 4. 1 into 4 is 4. 4 into a is 4a. So 4a is equals to 2 implies a is equals to 2 by 4, which is 1 by 2. 2 by 4 is nothing but how much? 1 by 2. So by eliminating these two terms, we got a is equals to 1 by 2. Now let us see the next substitution here. So this is our equation number 1. And what is the next value? By putting x is equals to 2 in equation number 1. So x is equals to 2. By putting x is equals to 2, which terms are going to get eliminated? Here we have x minus 2 term. So this will be eliminated. And here we have x minus 2 term. This will be eliminated. So now we are going to get the value for b. Okay. So let us see here. 2 plus 4 is equal to a into 2 plus 1 into 2 minus 2 plus b into 2 plus 2 into 2 plus 1 plus c into 2 plus 2 into 2 minus 2. Okay. So this 2 minus 2 term becomes 0. And here also we have 2 minus 2. This is also 0. So 2 plus 4 is how much, children? It is 6. 6 is equals to 2 plus 1 is 3, which is into 0. It is 0. Plus b into 2 plus 2 is 4. 2 plus 1 is 3. Plus c into this whole term is 0. Now these two terms are zeros anyway. So what is left now? Only b is left. 4 3 is how much? 12. Which is 12b is equals to 6. This 12 will be sent other side. It goes to denominator. That is 6 by 12, which is 1 by 2. B is equals to how much, children? 1 by 2. Okay. Now here, let us see here. B is equals to how much we got? 1 by 2. A is equal to 1 by 2 and B is also equal to 1 by 2 we got. Okay. Now the next one is x plus 4 is equal to, this is our equation. By putting x is equals to minus 1 in equation number 1. What I got by putting x is equals to minus 1. Minus 1 plus 4 is equal to a into minus 1 plus 1 into minus 1 minus 2 plus b into minus 1 plus 2 into minus 1 plus 1 plus c into minus 1 plus 2 into minus 1 minus 2. Wherever x is there, there you are replacing with minus 1. 4 minus 1 is 3 is equals to, this term becomes 0, and here also which term? This term becomes 0. A into 0 plus b into 0 plus c into 1 into 2 minus 1 is 1, minus 1 minus 2 is minus 3. Okay, so minus 3c is equals to 3, c is equals to minus 1. 3 by 3 is how much? 1. So minus 3 goes other side, it becomes 3 by minus 3, which is minus 1. So A, B, C, all three constant values we got, children. So now what is the next step to do? To replace in our partial fractions. Yes or not? So let us do it now. So what are the values of A, B, C? Let us write it again. A is equals to 1 by 2. B is equals to 1 by 2. And C is equals to, how much we got? C is equals to minus 1. Okay. And what is our equation of partial fractions? Since x plus 4 by x plus 2 into x minus 2 into x plus 1 is equal to a by x plus 2, no? That is a by x plus 2 plus b by x minus 2 plus c by x plus 1. So this is the equation of partial fractions what we have. Let us replace a, b, c with these values. So that is x plus 4 by x plus 2 into x minus 2 into x plus 1 is equal to 1 by 2 into, sorry, 1 by 2 by 1 by 2 by x plus 2 plus 1 by 2 by, b is also 1 by 2, no? 1 by 2 by x minus 2 plus c by, c is what? Minus 1. Minus 1 by x plus 1. So sending this constants, because here the numerator we have a fraction, I'm sending this 2 downwards. So which is nothing but our, what is our final answer? X plus 4 by x plus 2 into x minus 2 into x plus 1 is equal to 1 by 2 into x plus 2. When this 2 comes down, it becomes multiple now here. Yes, 1 by 2 into x plus 2 plus 1 by 2 into x minus 2 plus into minus is minus 1 by x plus 1. So this is your partial fractions. These are your partial fractions. If you observe here, here the first two terms are sum of the terms, and here we have the negative sign. Means here it is a sum of the given proper fraction is split into 3 partial fractions. Is it clear, children, how to write, how to split into any given fraction into partial fractions? I hope you are following. Now let us see what have we learned in today's class. Okay. So what is a rational fraction? So what we have learned in the first session, the first beginning of the class, children, a rational fraction is what is called as a proper fraction. What is a rational fraction we have learned, and rational fraction is called as a proper fraction. The degree of f of x is less than the degree of g of x. And what have we learned? What is an improper fraction? If the degree of f of x is greater than degree of g of x, then it is called as an improper fraction. And next thing, what have we learned? If a proper fraction is expressed as the sum of two or more proper fractions, wherein the denominators are powers of irreducible polynomials, then each proper fraction in the sum is called what? Called a proper fraction of the given fraction. Okay, it is about the partial fractions. Next thing is what? Partial fractions of f of x by g of x. And g of x contains non-repeated linear factors. So here we try to write the given proper fraction as partial fractions, where the denominator g of x contains non-repeated linear factors. So here we have different rules are there, children. In today's class we have discussed rule 1, where the g of x contains non-repeated linear factors. Okay. So in the next session we can learn about the other rule. Okay. So, and here how far you have understood. Let us check your test your understanding. Means I am giving you some practice questions, children. Try to do it. Okay. See the video once again. You can read the, you can see the lesson once again and understand it thoroughly and try to do the sums. Okay. So the first question is what? Resolve 13x plus 43 by 2x square plus 17x plus 30. into partial fractions. So what is there in the denominator? It is a quadratic, yes or not? So whenever a quadratic polynomial is given to us, so it can be split into product of two linear factors, yes or not? So how to split into linear factors? Already you know it. Okay. So what is that, children? It is what? It is what? Using factorization method. Yes, it is what? It is a factorization method. So now second one is what? Second question is resolve 2x plus 3 by x plus 1 into x minus 3 into partial fractions. Here directly I have given you the sum where the two linear factors are there. Okay. So next one is what? Resolve 5x plus 6 by 2 plus x into 1 minus x. So here into partial fraction. Here in this question, children, it is also similar to this one only, but here should be little careful, okay? Because here in these two terms, x is there as the first term, yes or not? But here if you observe, it is written as 2 plus x, and here it is 1 minus x. So whenever you are doing this sum, x value, whatever is the factor, always remember that by giving how much value for x, this term will get cancelled. Only that much you have to check, okay? Whether it is x minus 1 or 1 minus x, whatever it is, see it properly, okay? So these are the sums what I am giving to you, children. Practice these questions and see the, if you have any doubts, see the video thoroughly and understand it properly and do the sums. Okay. Thank you, children. Thank you, ma'am.